Ladies and gentlemen, welcome to machine learning. In this video, we will cover the expected value of random variables, the variance, and the covariance. Let's jump right in. So the expected value is if we have a random variable, we have a probabilistic expected value of the result of this experiment. So for example, if we throw a dice, we have a random variable that is the face of our dice ranging from 1 to 6. And we expect a certain value. If we throw it multiple times, we already know, well, it's probably not going to lean towards the 6th and it's not going to lean towards the 1. It will somewhere be in the middle. So this will be a great example for the discrete case where we have a expected value where we just sum the probability of that value times the value itself. So if we have a cube, for example, we have 1 over 6. We have 1 over 6 times, for example, the first throw was a 1 plus 1 over 6 times 1 over 6 times 3 plus 1 over 6 times 4 and so forth. So then we will get the expected value of our dice. And we can generalize it if we want to do something with the face of that value, we square it or something. We can just simply apply this transformation onto our x, and we will get the expected value of this function of x. So again, we multiply the probability with the value of our random variable and sum over all the values. If we have a continuous case, we do the same thing where we have the expected value, we multiply the probability with the value itself, so x, and then we take the integral over this whole x, so over the whole domain. And again, if we have a function where we apply some transformation onto our x, we do exactly the same thing. We have a probability, C stands for continuous, multiplied with f of x and integral over dx. If we do not know the exact probabilities, so if we don't know the probability of having the discrete case, we can just simply perform this experiment multiple times, optimally infinity, and then just sum the values from 1 to n. So we perform the experiment multiple times, we get a 1, or throw a dice multiple times, we get a 1, a 3, a 4, a 5, a 3, a 4, a 1, a 2, a 1, a 1. So we do this many, many times. We sum over all these values and then divide by how many times we perform the experiment, and then we will again get the expected value. The variance is a measure of how much a random variable, so for example, again, the dice throw, differs from the expected value. So if we know the expected value, we can throw the dice multiple times and see, well, how much does it vary? If, for example, we have a dice that has a mean, for example, around 3.5, and we have many times a 4 and many times a 3. This will be a different variance to where we have again the mean at 3.5, and then again we only throw 1s and 6s, or maybe I should do 1s and 6s. So we mostly throw 1s and 6s or 3 and 4s. So this will, the variance will give us that value. So here we have a only slight difference, and here we have a large difference. To get the variance, we simply can compute the expected value of our squared values minus the square of our expected value. So this is our simple case, and in general, we can have, again, the expected value of our function squared and the expected value of our function squared outside. We have some properties of those random variables, and that is if we have a random variable ax, so our a f of x is simply a times x, we can factor the a out and we get a squared times variance. If we have a variant of a constant, we will get 0 because a constant does not vary. If we have a variance where this is our f of x, we add another a constant term, we have a variance a plus variance x, and this is simply just the variance of x because variance of a is equal to 0. If we have multiple variables, we will talk about the covariance. So the covariance is a measure how much two random variables vary together. And we get the covariance by having e, the expected value of x times y, minus the expected value of x times the expected value of y. Here we have also some properties. So if we talk about the covariance of x and x, that is actually just the variance of x. And the covariance is symmetric, so the covariance of x and y is the same as the covariance y and x. If we have the constants, we can again factor them out and we'll see the same as we saw before, but this time without a square, so we can just simply move them to the front. We get AB times the covariance xy. If we have a shift, so just a simply positive shift with a constant, it does not change our covariance, so the covariance stays the same. If we have ax plus by and cz, we just use a simple multiplication where we have the covariance of that, and again the covariance of this and this, where we factor out our constants and we will get these two terms. So AC times covariance x and c, and the covariance y and z. Sorry, this is AZ. And if our covariance of two variables is actually 0, we say that x and y are independent. Now, a short example to understand what this actually is. So let's say we have a variable x and we have a variable y, and we get from x, we get 0, 1, and 7, and for y, we get 2, 5, and 20. So this was experiment 1, experiment 2, and this was experiment 3. The expected value of our variable x is 1/3 times 0 plus 1 plus 7 is equal to 8/3. The expected value of y, the same thing, is equal to 9. Now we want to know the covariance. So the covariance is the formula x times y minus ex times ey. And now we want to find the expected value of x times y. So we just multiply these values together and we get this one. So 0, 5, and 140. And the expected values of xy is 145/3. Now we can insert all these numbers and we will get this expression where we see that the covariance is 24.3. The variance of x can be also determined where we just simply take the square of our x values and subtract the square of our expected value of x. So what is the square? The expected value of the square of our variables, it's 0 plus 1 plus 49 divided by 3 is 50/3. Inserting it here, we will get these two terms. 8/3 is the value we got from here. And we will see that the variance of x is 9.5. And the same can be done for our random variable y. I hope this video gave you a better understanding and a refresher in your knowledge about the expected value and the covariance. If you have any questions, feel free to ask them in the comments down below. Thank you very much, and I'll see you next time.